Stream and you should work, right? You're gonna work? Nice. Okay, and I need to get the link. I wish it would just tell me where the link is. Whatever, I'll deal with that later. All right. Well, in that case, hello and welcome. This is the Gumby meeting for networking. There's going to be 3 of them. This first one is going over IP and stuff, although I can actually move forward and it can tell you. So, topics today, we're going to go over the OSI and TCP models, IP addresses, both as well as subnet masks and subnetting. And this, again, is a very, very high-level overview. All of these things you could probably spend an entire class learning about and still not really scratch the surface. So those are these. Then we got MAC addresses, TCP and UDP, which I think I forgot to edit that. That should not be there. That's next time. This I needed to edit. All right, whatever. Cool, whatever. This is the OSI model. You're going to hear a lot about it. It's basically all over the place. It's used to help people understand what exactly things are doing and what's happening on a network. It also allows for easier standardization. There's 7 layers. So we have up here, this is layer 7, 6, 5, 4, 3, 2, and 1. And all of these happen within your computer except for the physical. Physical is when it actually goes on to the network itself. So yeah, and they each deal with different things, different applications. There's also the TCP model, which is an alternative to the OSI model. It can be basically directly translated. It's more modern as well. So here's the OSI model. So again, the top is layer 7, which is the application layer, where things like HTTP occur. Below that's presentation, where compression and encryption occurs. Session, which is tunneling and things like that. Transport, where TCP and UDP occur. The network, which is IP stuff. Data link, which is Ethernet. And then physical, which is like actual physical cables. And then all these random ones up here, application, presentation, are all just application. Transport is the same. Network becomes internet. And then the network interface is the data link layer as well as the physical layer. And that's basically the difference between the TCP and OSI models. Again, they're reference models. You're going to be hearing about them a lot. Yeah, so you will need to know this. It's very, very, very useful. Generally, what happens, and if you look at the diagram here, data flows up and down the model. So this is the transmitting device. It starts with the application and has HTTP data and then compression and session. It goes all the way down to the physical layer, which is the packets themselves, which are sent as a byte stream across the network. And then when it's received on the other side, it goes right back up the OSI model all the way to the receiving application. And so it goes both ways. The main ones we're going to be concerned about are the transport layer, which is going to be next time, not this time. The network layer, which is IP stuff, and the data link layer. The physical layer is going to be networking 3. Each device between the start. Okay, this is another interesting thing to note. So this is not necessarily you go up all the way up and all the way down. If I have my computer here and I'm like on YouTube or something, it's going to go from YouTube, which is HTTP application, all the way down to the physical. And then the next stop from this is where my network interface card is, or the NIC, or your Ethernet or Wi-Fi or whatever. It goes from that, and the next stop, let's say we're on an Ethernet, a physical Ethernet network, it's going to go over from the Ethernet to the switch. And the switch is what's called a layer 2 device. You can see that here, which means it's only really concerned with MAC addresses and stuff. You can get layer 3 switches, which can look at IP traffic, but generally a switch is a non-smart switch is going to, or an unmanaged switch is going to be the data link layer. And so it goes from the data link layer and figures out where the next MAC address is, and then goes out, and let's say, so that'll be the transmitting device again. And then it goes to the router, and it just goes from hop to hop to hop until it finally gets to the destination, where it goes all the way up the layer. So that this model happens at every step, both in devices that you may not actually consider, like your Wi-Fi access point would be using this model as well. All right, so OSI model, super important. It's kind of complicated. There's an exam you can take, or that you can at least practice for. I probably wouldn't take it. Called the Net Plus, that goes over a lot of this stuff in detail. And the first thing you always learn is the OSI model. So IP addresses, it's a layer 3 on the OSI model. So that means it's dealing, IP addresses. And a layer 3 switch, as I had mentioned, means that it can make decisions based on IP addresses and other layer 3 features. Each IP address, at least for IPv4, which is all we're going to be worrying about, contains 4 bytes or octets separated by dots. I'm sure you recognize this. So each number is from 0 to 255 on all of these. And all IP addresses need a subnet to function. Here's some basics on MAC addresses. MAC addresses are used to give subnetting and network information to the IP addresses. They are also 4 octets long, separated by dots. And it's basically a string of 1s followed by a string of 0s. So for example, this 255, it means there's 8 1s, another set of 8 1s, another set of 8 1s, and then 8 0s for the whole IP address. It can be written 2 ways. This is the standard one that you've probably seen a lot, which is pretty self-explanatory. And there's also the CIDR notation, which is below here. The CIDR notation is usually tacked on. I'm just going to stop moving my mouse, but it's below. Tacked on to the end of the IP address. And it's basically telling you how many 1s are in the MAC address. So since 255, 255, 255, 0, that MAC address has 24 1s. It's just a /24. Generally, this is my preferred. This is a lot of people's preferred way of representing it, just because it's more compact than writing a whole other set of 8 octets. IP addresses also have classes, right? And this is just kind of the way it was designed. I'm not exactly sure why. The class determines the size of the host identifier, which is this. The host identifier is basically the part of the IP address that you are really concerned with. The network identifier is really just pointing to the network itself. Class A, Class B, and Class C are used for hosts. Class D is used for broadcast. And Class E is reserved for experimental purposes. Who knows what that means? You can determine the class of the octet by the first value. You can see it here. So for Class A is 0 to 127. the first octet. B is 128 to 191. C is 192 to 223, etc., etc. And the usual subnet mask is also included here. So for class A, it'd be 8. So it would be a /8 or 255.0.0.0. 16, 255, 255.0.0, and then 24, as we saw before, for class C. And this is very, very high level overview. If you have any questions, unmute yourself and say. Although keep in mind this is on YouTube. Yeah, more IP addresses. So there are also reserved IP addresses for special use cases. Your local IP address, which these are the local range for your home network, for example, which is this one down here, which you've probably seen, is usually the default. So 192.168.something.something is that range that can be used for it, for a local network. The .something.something, it can be anything from 0 to 255 in there. Most of the time it's either .0.something or .1.something, since it's usually a /24. Same thing with the class B, although this is a little bit different. Instead of just having the whole second octet open, it only has 16 to 20. That should be 31. This should be 31. 16 to 31. And then these are decided by deciding your subnets and such. And then the largest is class A, which has the full 3 ladder octets, which is just 10.something.something.something. You also have the loopback address, which is pointing to your PC, and the APIPA address, which if you see a 169.254.something.something, it means your DHCP is broken. If your computer doesn't have an IP address, a static IP address set, and it didn't get if the network isn't telling it what IP address it has, it just generates one in that range, and uses it. Generally, it's you broke your DHCP at some point. DHCP is the thing that tells your computer what IP address it has, by the way. So, subnets. Subnets are used to split your network into different segments. I think I have a better slide on this. But this is kind of the reason why we have the MAC address and the IP address. It's used for subnetting. So to calculate the network address, which is like the start of this particular range, you would, on each bit along the IP address and the subnet, you would just AND the two together. So there's the truth table over here. So basically, if they're not both ones, it's a 0. And so because all of the first part of the subnet mask is all ones, it basically means I don't care about because the first one part of the subnet mask is all ones, it copies basically bit for bit down to the final. So this 201, this 10 and 1 are all copied straight up. And then all the zeros, because a 0 and anything else, anything with a 0 is a 0, it means that it zeroes out those, and that tells you the start of the subnet range. And hopefully I made it a better slide. Here it is. So what exactly is a subnet? I think this should have come before the last one. A subnet is used to split a network into pieces. Each subnet is unaware of the other subnet. So if you're on subnet A and your friend's on subnet B, it's basically like you're on separate networks. You'd have to do some shenanigans to get them to be able to talk to each other, and that's using routing, which is a layer 3 thing. Oh, I just I tapped the escape button. Oh no. I tapped the escape button. Screen share. Okay. We're back? Yes, we're back. Okay. Oop. And subnets, it's used generally for security. In fact, the FBI actually recommended keeping IoT devices on a separate subnet to normal people. So, I mean, that just shows you how insecure IoT devices are if they're recommending normal people to understand what the hell is happening here, right? But yeah, because they can't really communicate with the rest of your network. If a IoT device is compromised, it's probably not going to completely destroy everything on your network, which is quite nice. Subnets unable to seek, shared devices. And then for businesses, you might want to separate different departments like customer service and management. So if you weren't to do that, it would be relatively straightforward for, let's say, me. I'm just Joe Schmo in customer service, and I think I want a pay raise. You know what I can do? I can just go onto the server that manages all the payroll and just add a couple zeros on. And if it's not separated and doesn't have other security measures, I can just do that, which is kind of crazy. So yeah, you're separating it for security reasons, and that's the main thing. And again, to calculating the subnet, generally speaking, people use calculators to calculate the subnets. It's a lot easier than doing it by hand, but if you're going to do this for like a class, they may ask you to, which is kind of a pain. So more subnet stuff, right? So the class is going to determine the network prefix. That's this guy right here. And so since this is 172.16, that means these first two are deciding the network, and the latter two are deciding the subnet. In the IP address example here, with the MAC address, since 201 is a class C address, if we go here, here, 201, yep. So 201 is a class C. That means the only bits we're going to be worried about are this last set, or I think generally speaking. And because this has 128, which means this last bit is 1, that means this bit here is the network or the subnet address, and all the others define the hosts, right? So this means if I have this subnet 0 or subnet 1, that would change which network they're on. So if I have this IP address, or let's say it's 129, and I also have 127 as an IP address, those won't be able to communicate because the subnet mask is telling me that that last bit is different, and so they shouldn't communicate. And so yeah, the bits after the prefix, the 1 bits after the prefix are deciding what network it's going to be on, and the zeros after are deciding what host it is. So in the example here, we have 172.16.2.15. It looks like they're using a /24 subnet because this entire octet is taken out. So that means this bit is telling us which subnet it's on, and this bit is telling us which device it is. Cool. And wow, that was shorter than I thought. Cool. So yeah, that's networking. Next time we're going to be going over TCP and UDP. as well as looking at an actual network and doing a demo on pfSense and Wireshark. Do you guys have any questions? Do you want me to go over anything? Because I did kind of run through it, and I know a few of you came in after. Let me pull up the text chat in case you say anything. So that'd be Gumby stream Q&A. It all kind of seems esoteric, but the more you get into networking stuff, the more you're like, oh yes, it's like the word the. You use it a lot and you don't really think about it. Oh, I think I already talked to you, didn't I, Nate? So the Network Plus, there's a few things to consider when you're getting certificates. First off, oftentimes you need to pay for the test. Now, if your company is paying for it, doesn't really matter. And second is different certificates are valued differently in the community. Generally, certificates that I understand are quite good. There is the Security Plus from, I don't remember what they do, Security Plus exam. There's CCNA, which is for Cisco networking. And then there's also Red Hat System Administrator, which is super, super good. And like a lot of things in life, there can be, Security Plus from CompTIA. There can be different, you can overdo it, right? So if you have just one, the employer may be like, oh, he must be just starting out. Maybe I should hire someone who has a little bit more experience and a few more certifications. So 3, they'd probably be pretty happy with. But if you have a dozen, it'd probably be a red flag because they'd be like, okay, so why does he have all these certifications and is looking for a job? Is there something wrong here? And it's going to kind of, it's just going to be a little bit of a red flag. It obviously depends on the employer and such, but you want to be careful with how many you get. Don't just get all the certifications that you can, because it can be a red flag. So generally, like, I'd say 3 to 5 is probably a reasonable amount if you're going for that to be a big resume booster. Yep. Let's see. Websites. On YouTube. Let's see if I can find it. I used to have a prep thing for the Network Plus, but I'd have to find it. Let's see. Okay, so this one seems reasonable. I will post it here. So that's a YouTube series that goes over all the stuff contained in the Network Plus, and then I will also post it in the live stream for people. As you can tell, it's a lot. The dude has over 100, anywhere from 5-minute to, let's see, there's a 20-minute one, a few 10-minute ones. Yeah, anywhere from a couple minutes to, oh, this long one is 22 and 33 seconds. So yeah, there's a lot of content. This subject is very, very deep. Generally for when you're working with the stuff we do in the Cyber Dogs, this is not something you're probably going to want to really memorize, but it is something you're going to encounter a lot, and having a surface level understanding is going to be very, very good for you. So, for example, let's say you're playing in CDE again, right? And your network goes down. Understanding what IP addresses are, what are the components that you need to be able to connect to the network, is going to help you figure out what exactly was borked on your system. Usually it's firewall things or red teams just being mean. But in real world examples, if you're a lot of times, and Nicola, I'm sure, can attest to this, you may be able to get to a IP address, right? So go to Google's IP address, but you can't go to google.com. You can use that information to try to find. It's probably going to be DNS, because DNS is or domain name system is telling you what IP address is associated with what website URL. There's other things like the APIPA address, which I had somewhere right here. If you see that when you do IP config, it's telling you that you're either not connect, or it's telling you that your DHCP is not working, or you don't have a static IP set up yet. There's also other things, like if you're the what is it, default route, I think, or the basically where your computer is going to your router. If it's not pointing to the router, you're not going to be able to do a whole lot on the network. Yeah, there's a bunch of stuff. Any other questions? It's probably pretty great, because in the firewall meeting, we did like 3 slides on networking, and it probably made more sense than this, but this had a lot more details in it. So I don't know. Yep. So for next time, again, an actual network, this is going to be kind of showing a diagram of what a network might look at like, or like a power user's home network, not necessarily a business network. pfSense is a router software. It's open source. You can download and mess around with if you want. And Wireshark is a packet sniffer. So yeah, we'll look at some network traffic with that. Yeah. If that's all the questions, I think I'm going to end the stream and just hang out, probably. I'm not going to touch on intrusion detection prevention systems yet. I may mention them, but that's a big topic. All right, cool. And then where's the